Hey everyone, welcome back. In this video, we are going to walk through one of the most popular authentication flows used by secure web applications, the OAuth 2.0 Authorization Code Flow. If you've ever logged into a site using login with Facebook or sign in with Google, chances are this exact flow was used. Let's start by understanding what OAuth 2.0 is and who's involved. Then we'll dive into the real-world flow step by step. So, what exactly OAuth 2.0 is? OAuth 2.0 is an open standard for authorization. It's not about verifying who you are, that's authentication. It's about verifying what you are allowed to access. Think of OAuth 2.0 as a delegation protocol. It allows a user to give limited access to their resources on one site without giving away their username and password. For example, you can let Booking.com access your Facebook profile data, but you are not handing Booking your Facebook credentials. OAuth makes that safe and possible. Now let's quickly look at the four main players in an OAuth 2.0 flow. First is the resource owner, that's the user. It's their data we're talking about, so they control the access. Second is the client. This is the application requesting access to the user's data. In our example, that's Booking.com. Third is the authorization server. This is where the user logs in and authorizes access. That would be Facebook's secure login interface. And finally, the resource server. This is where the user's data actually lives. Facebook might separate its login system from its data access system. So sometimes the authorization server and resource server are different, sometimes they are the same. Now that you know the players, let's walk through the full OAuth 2.0 authorization code flow, the most common and secure flow used by confidential web apps. Step 1. The process begins when a user visits a web app. In our example, Booking.com, and clicks login via Facebook. The user is the resource owner here. This action tells the client application, Booking.com, that the user wants to authenticate using Facebook. Step 2. Booking.com then redirects the user to the authorization server, which is Facebook in this case. The user is now no longer interacting with the client app directly. They are being taken to Facebook's secure authorization interface. Step 3. At this stage, Facebook shows the user a consent screen. This screen outlines what data Booking.com wants to access, like profile info or email address. The user reviews and confirms the authorization. Once they grant permission, Facebook has the green light to proceed. Step 4. Now Facebook, acting as the authorization server, redirects the user back to Booking.com, but not empty-handed. It sends back an authorization code via a pre-registered redirect URL. This code is short-lived and can be used only once. So far, Booking.com still hasn't received the user's credentials. That's an important part of OAuth's security design. Step 5. With the authorization code in hand, Booking.com now makes a back-channel request to Facebook's authorization server. This request includes the authorization code, the client ID, and the client secret. Credentials known only to Booking.com and Facebook. This step does not involve the user's browser anymore. It's a secure server-to-server call. Step 6. If everything checks out, the code is valid, the credentials are correct, Facebook responds with an access token. This token represents the user's authorization and can now be used to access the actual protected data. Step 7. Now, Booking.com presents this access token to the resource server, which again is Facebook's server. Booking.com might ask for user profile details, friends list, or email address, depending on what scopes were authorized earlier. Step 8. Finally, Facebook's resource server checks the access token. If valid, it returns the requested protected data back to Booking.com, and the user is successfully logged in. At no point did Booking.com ever see the user's password. All access is securely managed through tokens. So what makes this flow so secure? The key is that sensitive tokens and credentials are exchanged server to server. The user's credentials never touch Booking.com, they stay with Facebook. And the access token can be limited to specific scopes like read-only profile access. This is why the authorization code flow is recommended for confidential web applications, the ones that run server-side and can keep secrets safe. Thanks for watching, and I will see you in the next one.